So, hello and welcome everybody. So glad to welcome you all here. You're all excited to learn more about how to make your laboratory more sustainable. And who could tell you better than Dr. Jan-Hendrik Bebermeier? He has studied biology and has been with Eppendorf after his PhD since 2005 in different responsibilities for different product groups. And right now, currently, he is a global marketing manager for our cold storage and sustainability products. So I give over to you, Jan, and you all enjoy.
Yeah, thanks. So, welcome from my side as well. Actually, the cold storage brought me to the topic of sustainability because, ULT freezers, they are known for energy consumptions and cooling liquids, and that is a dedicated topic for sustainability. And if we are honest, as scientists, we see, sustainability in the lab is not only limited to water consumption, electricity consumption, or plastic consumption, but also to other aspects. And I think most of you are focusing on the environmental, the green aspects, but sustainability also includes social topics like the ergonomics in the lab, the well-being, but also economic, so financial stuff, like if you do an experiment 2 times, 3 times because you used sub-cool or sub-good quality products, that is also a question of sustainability because you're wasting capacities, wasting resources, also working resources. So sustainability is really a topic which covers all these 3 columns. And unfortunately, you cannot win all 3 in parallel. You always have to focus on 1, maximum 2, because there's no compromise between them. So when we talk about sustainability in the lab, there is something like a growing interest of the users. So more and more scientists are asking us, okay, what can you do? What can we do about sustainability in the lab? The major topic of everyone is, I assume, is really plastic. So what are we doing with all the amounts of plastic waste we have every day, every week, every month? And that's also part of sustainability communication. We need clear answers, which means currently there's no solution for the plastic. We'll come to that later in a minute. Another topic are cooling liquids for centrifuges and freezers. There we are lucky, so in the moment, nearly all new ULT freezers are using hydrocarbon cooling, so more sustainable liquids for the cooling system. Power consumptions. Who cares about power consumption in the lab? You are not paying for the power, huh? It's the institution. But we see it also more and more that users are asking us, okay, how much power is your centrifuge really, does it consume? Then the question about service and how long can you get spare parts? So for example, we guarantee you that we have 7 years after you purchase the product or after we stop production of this product, we can still provide you with spare parts for the instrumentation. Then the validation of data. I mean, I'm in marketing, so I can tell you whatever story you want to listen to, but the question is, okay, how trustful is that? I mean, you can trust me, but still, you would prefer, as being scientists, to have a third-party validation of data. So that means really, is that coming from the company who's selling me the product, or is it coming from a third-party organization like my Green Lab with the ACT label, or even Energy Star? Last but not least, the question is, okay, there's definitely a need for more sustainable products, but what about the pricing? And we have to accept that the price of sustainability product or more sustainable products will increase in the near future. That's something we will see in all life, so also in our consumer life, because we have to take into account costs which we so far ignored as a society, like pollution of air and water and earth. Actually, my first contact with sustainability in the lab was something like 10, 12 years ago when we launched a new generation of microcentrifuges. And we were able to prove, okay, we can save 20, 30% of power for these centrifuges. And internally, we were super proud of that and wrote some nice brochure. And our sales colleagues told me, yeah, but for what purpose? Because no one is asking for that. And we talked to users, and they said, well, the power is coming there from the socket. I don't pay for it, so who cares? And luckily, this changed now. So more and more people are really interested in getting data, real data, proven data. And Eppendorf founded, well, just after the war in 1945. And it's a little bit like the Microsoft story, actually, because we started in a little garage on the University Hospital area of Hamburg. And that's actually where the name is coming from, because this quarter of Hamburg is called Eppendorf. So the people just talked about these guys from this company from Eppendorf. So that was, over the time, the origin of the name. But our mission already from our founder fathers was to improve human living conditions, which is, I mean, at that time point, sustainability didn't exist as a word. But looking backwards, I would say that is already in this direction to think about the future and to think about what we can do. And in the meantime, we decided to do far more as a company, for example, for focusing on climate topics as well as resources. So to do our job as well to reduce carbon footprints, to do our job to limit global warming as far as we can, and to develop new product concepts. But that's more the corporate level. So the question is really, what can we do for you guys? First of all, we changed all the production facilities to green power in the last years, so that we can really say, well, we try our very best to reduce the carbon footprint in production for the products. So in case you are calculating your own carbon footprint in the laboratory, you can already get a lower amount of carbon products in by our portfolio. What we did so far is a reduction of carbon emissions in the last years by nearly 60%, just by switching to green power in the facilities. For sure, the next 42% will be far more harder for us to do, but that's our way, and that's the target. We don't know if we will reach it, but to reach in our own operations 0 carbon emissions in the next years. What we do is to cooperate with partners. Why is that? Because we know a lot, but we don't know everything. And for that purpose, we interact with My Green Lab. That's an NGO from the US. And they are offering this ACT label. Anyone is aware of this? Perhaps somewhere, no? So that is something which looks like when you buy a washing machine here in Europe, you get this kind of colored table as well. It's giving you indications about the impact of manufacturing, the usage, end of life, power consumption, all that stuff. And this organization is asking us as a supplier, okay, please provide us a lot of information about the life cycle. They check it. If they don't trust us, they ask us, okay, I would like to have a certificate about that. We want to have a signature of Eppendorf or Thermo or whatever company is providing the data that this is really true. And then they publish these values with a long list in their database, which is public, about information like what does the company do, what can be still improved. So it's not everything is nice, but they also give us homework there, which you can read. So it's an open system, and we try to really to have more and more products. And you see it here with this ACT label to provide you folks more information about the sustainability level of these products. And as mentioned, it's not limited to Eppendorf, but this ACT label you will find for most of the bigger suppliers already for some products, and the number is growing. Because it's an independent label which gives you the freedom to see or to understand the information. So I promised you, okay, how can we improve the situation in the lab? So how can we reduce waste? Because we have far too much waste in the lab. I mean, when we look on these nice glory pictures of the marketing department, there's no sign of waste, of dirt, of used stuff. Actually, when we did the first talks here on this topic 2 years ago, I checked our database, and I can tell you we have, I don't know, 10,000 of pictures of our products, and there was not a single one of used consumables. So even at Eppendorf 2-3 years ago, that was not a topic because it was just moved away. The waste was collected by the waste company, all fine, all good, it's gone. Like at home, where every week the waste bin is emptied. But the question is just, what about these guys? Used plastic. And the question is really, okay, what can we do? We can use different raw materials. We may reduce in the lab. We may recycle. What can we do? And the first step, when I get a new product, it's wrapped in cardboard. So just assuming I will get a new centrifuge, a little one, not the big one, heavy one, in a cardboard box. You're happy, you receive it, you take this cardboard box in your lab, put it on the bench, and remove the centrifuge. The cardboard box, normally it's recyclable, but if we're honest, it's now on the bench, which is a contaminated area. So this cardboard is contaminated. But you can remove the centrifuge out of the box on the hallway, in your office, wherever it's clean, because it's still a clean instrument. Then you can put the cardboard in normal recycling. The same for the plastic wrapping. Or if you have a box with 10 boxes of tips, remove the cardboard outside the lab, because then it's normal waste for recycling processes. For sure, if you have donation boxes for these kind of stuff, it doesn't make sense to remove the cardboard, because the box is the donation box. What else? I mean, the wrapping of these plastic is kind of tricky, because for sterility reasons, we do have some composite material here. So what is composite material? It's made of 2 or 3 different types of plastic which are melted or glued together. Pretty difficult to recycle. And that's our job now, to find some foil which provides the same, let's say, quality about sterility for you folks, but is still easy to recycle. So that's on our task. On the other side, to remove plastic for these single wrapped tubes or tips for super pure applications, it doesn't make sense to skip the packaging, because the purpose of the packaging is to have 100% sterility at the very bench. So that's something where it doesn't make sense to remove the packaging outside. Or when I'm planning to do some pipetting scheme, I mean, as a scientist, you could do just using 8 samples for reagents, doing the pipetting steps one by one. Or you think first and act second, which makes sense as a scientist anyway, to think a little bit before you start working, to make a master mix. And then you're ending up, instead of having 40 tips, you just end up with 13 tips, plus a tube, but still less plastic, without any compromise on quality or performance. So it's just by making a good plan for your experiment. Or the question is, everyone is aware about 15 milliliter and 50 milliliter. And if you open your freezer, I bet there will be a lot of tubes just with a tiny fraction of liquid inside. So the question is does it make sense to switch from 15 to 5 milliliter tubes, or from 50 to 25 milliliter? Because you don't need the complete volume. And for sure, that will not fit for every sample. But at least for some, it makes sense to adapt the tube size. Why is that? Because on the one side, you save a lot of plastic, like you can see on these numbers, 30 to 50%, or 20, 26% here. But also in the freezers, you save a lot of space. Because for one 50 milliliter tube, you can put nearly 30% more 25 milliliter tubes. Or even better, for the 5 milliliters, that's 100% more tubes in the freezer. So you save investment in the freezer, you save investment in power, and you save plastic for the environment. Then we also have to do our own homework, which we did two or 3 years ago, to check or to change the packaging of the boxes, the racks, the tip racks, by just changing the style of this box, by saving then 20% of plastic. Or there are still people who are using single-use boxes only, although they are refill boxes from all the suppliers available for 15, 20 years. And these boxes you can use up to 100 times, complete sterile, and you save nearly, far above 50% of plastic in total for 100 boxes as alternative. So that is the way you can save plastic in the lab. Well, are there other options? For sure, I mean, if we look on the raw materials, we are here somewhere in the center. All the plastic is made out of fossil oil, which is, as we all know, somehow limited in the availability. There are some guys who ask, well, what about the good old days of having glass material? Glass, that was this super expensive, very energy-intensive material of the old times. And honestly, that is no way back. So we have to check what can we do as an alternative. So in the near future, like in these times, what about bio-based materials? What about recycling materials? What about biodegradable polymers? So that's something where we as a supplier have to focus on to think, okay, what kind of options do we have there? First of all, recycling of plastic. We try to collect actually tip boxes to check, okay, can we do some recycling? And the problem, first of all, is they are contaminated officially. Then you have to keep them as clean as possible as plastic, so polypropylene only. And I mean, if you're in a lab team, everyone agrees to put just the polypropylene boxes in this collection container. There's just one stupid guy putting in there some polycarbonate. This polypropylene bag is kind of mixture of different plastics. And then it losing value when you go to a recycling company. So you have to really to concentrate your material. You have to reduce the chemical and contamination load. And then you need to find a recycling company which is really recycling the plastic on a proper level. And not just doing it like using it for street materials or for flower pots or park banks, which is normally done by plastic recycling. So we are, at least at Eppendorf, we are still checking how to find a way to do some proper recycling. And the next question would be, okay, if recycling is so complex, why don't you use other recycling material, like from the consumer area, like we do it with our, it's called the green dot in Germany. Because when we go to the drugstore, every shampoo bottle is telling you proudly made of 100% recycling material. Why couldn't they do it for the lab stuff as well, for these guys? Well, if you look on the shampoo bottle, they are mostly black, blue, green, red, silver, gray, you name it. And the point is because they use a complete mixture of all different recycled plastics, independent from the color. If you want to have crystal clear plastic, you need to use 100.0% of clear recycling plastic. That is far more expensive and you don't get it. But that's just an optical issue. The more critical part is recycling material is leaching. And that means if you do some chemical analysis, you always have this peak there, which you don't want to have because you're contaminating your samples. So far, at least, we are not able to produce clean plastic for you folks in the lab, which is free of these leachables, because in the recycling material, it's just too challenging to make it. And don't get me wrong, there will be solutions in the near future, but in the moment, that's something we don't get. The next step, I assume, will be something that, well, there will be material which has no direct contact to samples, which will be made of recycling plastic, but material like tips, or plates, or tubes are still challenging. So we can say, okay, we can do little tips and tricks on our daily routine to reduce. Recycling, I would call it a topic for tomorrow. There will be solutions, but in the moment, we do not have a solution. But what about the raw material? And there we come to the question, okay, by using in the factory renewable power, we can already reduce the footprint. But the production is just a small, tiny part of the complete life cycle. So we have the raw material, we do have the factory with the production, the packaging, transportation, and then the disposal. And you see on the size of these symbols, they have different impacts. So what we did so far was pretty small. So we looked on the raw material, because that has some kind of impact. What can we do there? And we decided to go for food industry oil, which was already used for fries, for example, French fries, and to collect, well, there are companies who are collecting these food industry oil, clean it up, and make polypropylene out of that. And then finally, you ended up with tubes and tips made of renewable, already reused oil instead of fossil oil with the same quality. And that's something we can see here. So we have the classic fossil oil-based material, but we also have now the bio-based, which are based on renewable oil, and you cannot differentiate them. They have the same quality, the same stability, the same, well, taste and sense. They don't smell like French fries. It's just pure plastic. And that is the way to go. So in summary for this topic, we can say, well, we changed the packaging. We now have also the tips as bio-based material, and for sure we still work on the surrounding packaging, the boxes and the wrapping, how to improve that. Hopefully this year we will also have a solution there, how to improve. And then there was a question, okay, but how much do I save if I go to bio-based? How much CO2 can I save when I go to an alternative resource? And that's why we decided last autumn to have a life cycle analysis. So really to check from the cradle to the gate how much CO2 carbon is produced for the production per tube. And we selected the 5 milliliter tube as an example. So we sent a lot of data to an external agency. They did a lot of work on that. So it took us, I think, or took them something like 4 or 5 months to do all these stuff. Then this report was sent to a second external validation company. And then we, poor sorts, got a 100-page report about the footprint of our products. Those data we will publish soon. So in the next weeks, there will be some flyer and white papers because we want to share these results. But I will share today already with you. The carbon emission savings for this tube with the current bio-based version is 18%. On the first glimpse, it looks like, okay, 18%, what's the guy talking about? That's not really a lot. I would expect 50% or 100%. Yeah, that was the same impression on our side in the beginning, that we said, okay. But the problem is for us, we already use green power in the factory, so that was no improvement. Plus 18%, I mean, that's 1/5 of the complete tube. And how many tubes are you using per day? So all these little dots, they help to improve as well. And then we still have an issue on our side that we can only make the tube out of bio-based material because the lid is a different plastic. That's polyethylene, and the tube is polypropylene. And there's still no supplier for the polyethylene as bio-based. So we still have some room for improvement. If we would do that, and that's a scalable value, we would end up with 27% saving of carbon just for the tube, for a single tube. And then for sure, our sales colleagues said, oh, great to have one number, but we have 4 tubes. So what about the other numbers? And we tried to extrapolate the numbers from the little tube, the 5.5, where we save 3 grams per tube, to the other tubes. And you can see from the relation of the size and the weight, we do have 3 other values just to say, well, per tube, you can save by using bio-based material between 3.3 and 11 grams of CO2 per tube. And these values we want to share with you as well, not only here, but also as a real publication to make you aware of all these improvements. Because then again, if you do your own calculation, how many tubes you use in your lab, you can just multiply this number with the number of tubes, and then you know how much you would save as carbon emissions. So now we had some introduction, we had some kind of plastic discussion. What about power? Which instrument do you think will require the most energy in the lab? Potentially at the freezer, or the ULT freezer. That's the answer most of the people provide if we ask, okay, who is taking the most? Point is, it's not the freezer. Not only because I'm in charge of freezers at Eppendorf, so I don't like that answer, but the point is we have some measurements. And we see here, there are some freezers where you can see the power consumption per hour, which is between 280 watt to 400 watt. But in the center, we see a big centrifuge, which consumes 650 watt per hour. And for sure, the centrifuge is just running for an hour, not 24/7. So the freezer is losing the deal anyway if you go per day. But I think the message here is there are some more guys who are consuming a lot of power in the lab. And for example, if we increase the speed of this multi-purpose centrifuge, so these big ones, from, 15,000 to 20,000 G with this big fixed angle rotor, we double the energy. So then you will end up with 1.2 kilowatt per hour, just by increasing the speed by 30%. So there is a direct correlation between how fast you spin and how much energy you consume. But there are also ways to reduce energy consumption. So for example, that's now the last section here. For the freezers, you can switch from -80 to -70 for most of the samples. It has no negative impact on the freezer technology. And you save, at least for our freezers, we know it because we have an agency testing that, 30% less energy, just by reducing by 10% of the set point. Then you should regularly clean the freezer. That means remove the ice, clean the filter, because all that is unburdening the compressors. Keep in mind, I mean, the freezer is big. There's some area above the freezer which is perfect to store boxes. I know it because I did it in the past as well as being a student. So all the consumable boxes we just put on top of the freezer, and then we block the air ventilation of the freezer. So that means the freezer is getting warmer and warmer. The compressor needs to run harder and harder, and it's consuming more energy. So keep the freezer free and guarantee the ventilation. Think about inventory management systems. Because whenever you stand in front of the freezer, where's my sample? You have to dig and to dig and to dig. It takes time. The freezer warms up and needs to be recooled afterwards, consuming energy. And for that, there's a nice and funny freezer challenge from my Green Lab, so the ACT guys, who say, okay, let's do some kind of competition worldwide until June, where you can, as a lab team, participating just by measuring how much energy you can save if you clean up your freezer. And this challenge, I mean, it's a funny thing. It provides you information, or it helps you in the team, in the lab, to make everyone aware about, yeah, you should take care about the freezer and the energy consumption. For centrifuges, a little bit the same story. If you have a big centrifuge and a small one, and you just want to spin 1 or 2 microtubes, go for the small one. I mean, it's a little bit like you want to do some little shopping tour and you take the big SUV or the small city car. Think about the size. Use the smallest rotor. The lighter the rotor, the less energy the centrifuge needs or requires. Think about fast temp functions. So most of the refrigerated centrifuges do have this fast temp function already built in. That's a function where the suppliers, if it's Hettich, if it's Sigma, if it's Eppendorf or Thermo, already optimized as a program to have the best performance to cool down with the least amount of energy. So don't just put in 20,000 G and 40 degree for 1 hour. That's a waste of energy. If you want to use the centrifuge at 40 degree half an hour later, keep the lid closed because the chamber is insulated. So at least you save some of the cold air inside the chamber, saving energy. What about the biosafety cabinet? Close the sash, similar to chemical hoods. Make the sash down. It saves energy because then the ventilation system detects, okay, it's closed, I don't need to run full power. Switch off the lights if you don't need them. If there's still classic bulbs in the instrument, think about LED bulbs. A big topic are also UV lights. Who's using the UV light overnight? Oh, you're all well educated because 1 hour is totally sufficient. After 1 hour, everything is dead, or they are really the hardcore guys who will survive even a night by UV light. Besides, the UV light is aging. So after 1 year of overnight usage, the UV light is dead. There's no beaming anywhere. Reduce the loading, so that is already at the border, because every additional box will burden the ventilation system in the cabinet. So the ventilators will run faster, consuming more energy. Also, the pre-cleaning in the morning. Don't spend 1 hour waiting. Modern instruments, after 15, 20 minutes, you can use them. So no need to keep them running 1 hour before you use them. Gas consumption of incubators. Again, limit the number of door openings. Think about checking the seals if they're still tight. Think about, well, other equipment like fanless internal chambers. Check the gas consumption per hour and per day if you buy a new one. Water consumption is also a topic. Autoclaves, keep them filled. Autoclaves are really consuming energy. If you use a vacuum ejector, that's a waste of water. Think about a pump. Ice machines, also they are really, really energy consuming. And then I think that's already the last end. A lot of information are available at my Green Lab. They have a lot of online trainings for free. And we also try to share our information in checklists, white papers, application notes of our learnings just to give you the opportunity to improve your own conditions. And with that one, I think the summary is really we have to improve, all of us. We have to educate all of ourselves and to question our processes. Habits are difficult to change, but we have to change them. And bio-based material from the consumables, that is a way in the moment. We don't know, in the future we will get new technologies which are even better. But that's the way. And more information you will find online. Thanks a lot for your time. I hope you learned something. And we are open for any kind of questions or afterwards questions.